Hello everyone. In this video, I'll be discussing synchronous FIFO circuits. We'll be covering following topics: basics of FIFO circuits and applications, and then block diagram of a synchronous FIFO circuits, various operation involved, and the RTL code implementation of it. First, the basics. What is a FIFO circuit? A FIFO circuit is a specialized data buffer or a storage element in digital circuits designed to manage data flow. The word FIFO stands for first in, first out, indicating that the data entered first will be the first to exit, similar to a queue of people. As shown in the figure, data is written starting at location 0 and then stored sequentially in location 1, 2, and so on, up to 15, as data arrives. When performing a read operation from this FIFO, the data is read from location 0, followed sequentially by location 1, 2, up to 15. So we see that the data which entered first is read out first. Now let's look at some key applications. FIFO circuits or first in, first out circuits are commonly used in data streaming applications. This is where data must be processed in the exact order it arrives. FIFO ensures that the data flows smoothly from the entry to exit without changing the sequence, which is crucial for streaming. Another important application of FIFO is as a temporary storage buffer when there is a difference in processing speeds between two devices. In this setup, we have a producer and a consumer. Producer is the device generating or writing the data, and consumer is the device reading or processing the data. When producer generates data faster than the consumer can process it, a FIFO buffers helps temporarily store the data to ensure efficient transfer between the two devices. This way, we can avoid any risk of data loss or overflow. FIFO circuits play a crucial role in data synchronization between different clock domains. In real world applications, especially on SoC designs, multiple blocks on a chip often operate with separate clocks. FIFO circuits help ensure smooth and accurate data transfers between these blocks. By carefully managing the timing differences, FIFO circuits prevent data loss and corruption during transfer. FIFO circuits can be categorized based on their architecture and the systems or the applications they are used in. There are two main types: synchronous FIFO and asynchronous FIFO. A synchronous FIFO is a data buffer circuit where a single clock controls the data write and data read operations. This type of FIFO is used in digital circuits where producer and the consumer devices operate at the same clock rate. The synchronization between the devices is simple since they share the same timing. Asynchronous FIFO. In an asynchronous FIFO, data values are written to and read from the FIFO at different rates. This type of FIFO is ideal for data synchronization when the producer and consumer operate in different clock domains, or simply put, at different clock frequencies. The asynchronous design allows reliable data transfer even when the clock between the devices are mismatched. In FIFO memory element, two key terms define its structure: FIFO depth and data width. FIFO depth is the number of rows in the FIFO memory element. This is also known as the number of words the FIFO can store, indicating the capacity of the FIFO in terms of rows available for data. Data width. Data width is the number of bits in each row of FIFO, also referred to as the word length of the FIFO. It represents the size of each data entry in bits. In the FIFO circuit shown here, the FIFO depth is 16 and data width is 8. Together, FIFO depth and data width determine the total capacity and data structure of a FIFO memory element, allowing us to handle data flow efficiently in digital systems. Now that we understand the definition, application, and main type of FIFOs, let's dive into the functionality of a synchronous FIFO circuit. Here is the block diagram and key components of a synchronous FIFO circuit. First, we have I/O ports. I/O ports handle data entering and exiting the FIFO. Memory array. This memory array temporarily stores the data within FIFO. It is typically implemented using flip-flop or RAM cells. Write pointer. This write pointer indicates the memory location in FIFO where the next data will be written. Read pointer. Read pointer points to the memory location in FIFO from which data will be read. We also have two status flags in FIFO, full and empty. The empty status flag indicates if FIFO buffer is empty. When FIFO is empty, both the write pointers and the read pointer point to same location. For example, at the beginning of the operation, both pointers start at 0, meaning the FIFO is empty. For simplicity, we considered it at the beginning of the operation, but it can be any location. The point is, if in FIFO read pointer and write pointer are equal, then the FIFO is empty. The empty flag is essential to prevent invalid read requests when there is no data present in FIFO. Another status flag is full. This flag goes high when the FIFO buffer is full. Starting with an empty buffer, both write pointer and read pointer are at 0. As data is written, the write pointer increments until it reaches to the maximum capacity. Here it's 15, while read pointer stays at 0. At this point, the FIFO is full, and the full flag is set as high. This flag is critical to prevent invalid write requests when FIFO is full at its capacity. Let's look at the core operation in synchronous FIFO circuit. First, the write operation. During a write operation, the data is stored in the location specified by the write pointer within the memory array. After each write, the write pointer is incremented, moving to the next location for the next data entry. During the read operation, data is retrieved from the location indicated by the read pointer. After read, the read pointer is incremented, moving to the next data location that is to be read. When either of the write pointer or the read pointer reaches to the end of the FIFO buffer, it wraps back to the beginning, which ensures a continuous data flow. This combination of operations allows for smooth, reliable data management in synchronous FIFOs, especially useful when data needs to flow in sequence and continuously within the circuit.